So in this video, we're going to specifically focus on the derivatives of trigonometric functions. Now, if you want to take a look at the proof for trig functions, you can definitely find that in your textbook. It's going to involve a lot of trigonometry with double angle, half angle, some addition of angle identities, as we try and work on with proving with the definition of a derivative. So for the purpose of this video, we're going to kind of move past that because you can look in your textbook to find that, so we can really hone in on the actual differentiation process. So there are a couple things that I just want to give you that you want to put on a note card. The first is these two specific limits occur a lot as we progress through calculus. So this is something to put on a note card, that when you see the limit as x approaches 0 of sine x over x, that's going to be 1. When you see the second one, the limit as x approaches 0 of the cosine x minus 1 over x, that's going to be 0. Now, again, these are just ones that occur frequently, so I want you to have those in front of you. Now, you can prove this by using the table method, and you can see as we use the table method and we get closer and closer to 0, it is approaching 1. Or if you have a graphing calculator, you could graph this. Now you're going to notice there's that removable discontinuity here at 0. So it's not continuous at 0, but the limit does exist because it's approaching 1 from both sides. That's two ways you can prove it, but I really just encourage you to put those on a note card because they're going to pop up in questions that you're working pretty frequently. Now, again, note cards. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. You're going to want to really have these just in your memory. You want to know them quickly because we will be utilizing them extensively in this week, especially as we start applying the chain rule to these. Another thing I wanted to show you really quick is the graphs of these functions. So trigonometric functions are going to have a lot of horizontal tangent lines, so because they have so many max and mins. So it's going to be really important to keep in mind that when you're taking the derivative and setting it equal to 0, you're going to be getting multiple answers depending on the interval that you're looking at. So for instance, if this here is pi and this is 2 pi, I have a max and a min between 0 and 2 pi. Then if I start extending this out, I'm going to have more maxes and mins. So it's going to be really vital for you to look at what interval you're looking at, and to make sure that sometimes you're working in degrees or radians as directed in the lab. Now, as a tip from Ms. Robinson, a lot of students do find it easier to work in degrees and then convert to radians. If you find that you can really work in degrees and you know the sine inverse of 60, the sine inverse of square root of 3 over 2, and you know that in degrees, and you're able to slide it in the different quadrants in degrees, by all means, use degrees. Convert your final answers over to radians. So just whatever process you work with best for that trigonometry background, that's what I suggest that you do. Now here's a comprehensive view of all the trig derivatives. Here is another tip from Ms. Robinson. Notice that every trig function that starts with a C has a negative derivative. This is going to help you keep track of what's positive and what's negative in the differentiation process. So as you're trying to work on memorizing these, really keep in mind that the derivative of C functions is going to be negative trig functions. Now let's start to look at how does this apply to what we've been learning, okay? So if I'm working with a trig derivative, more often than not, we see it combined with a chain rule. So if I have something like this, the chain rule says we have to work from the outside in. Sine is what we consider to be the outside. So applying the chain rule, we're going to differentiate sine and we're going to recopy, because remember with the chain rule, when you're working from outside in, you differentiate one thing at a time. Then you're going to multiply the derivative of the inside. So the derivative of x squared plus 1 is 2x. And just for convention, we really want to write our variables in front of our trig functions, okay? That's just the preferred thing to do. So what you're going to be seeing a lot of in this section is actually applications of trig functions that are going to have those nice chain rule identities pop up. So what if I have something like this? Actually, let's use a different trig function. Let's use cosine. So if I have something like this, cosine squared of, let's say, 3x cubed plus, this is going to be a really convoluted one, but it's going to be a good practice one. So the question becomes, is the cosine what's outside? Is the exponent what's outside? Or is what's in the parentheses the outside? The outside is actually considered to be the exponent. So if this was x squared, my derivative would be 2x. So I'm just replacing that cosine and treating it like an x. So I'd have cosine, and remember, nothing else changes. You're recopying everything. So now that I've taken the derivative of the exponent, the next outermost piece is the cosine. So the derivative of cosine is negative sine. And I'm recopying the inside. And then I'm going to differentiate the inside of the parentheses to get 9x squared plus 4. So the deal here is, it's a convoluted thing. There's really no nice, pretty way to write this. I can take that negative in the front, and I can take that 9x squared plus 4, and I can move that to the front. But there's really not a lot that I can do here to simplify to make it prettier, but it's a good example for us to practice all variations of the chain rule. So I hope this video has helped you connect the chain rule to those trig functions, and I hope you've got some helpful tips. I think this week is going to be a great week because it's a little more narrow in our topics, and we're really just practicing those additional rules.